Hello. Today I am Professor Rose with another boring math lecture to put you to sleep. We begin today with addition and subtraction. There is no process in arithmetic which does not consist entirely in the increase or diminution of numbers. There is then nothing which might not be done with collections of pebbles. Probably, at first, either these or the fingers were used. Our word calculation is derived from the Latin word calculus, which means a pebble. Shorter ways of counting have been invented, by which many calculations, which would require long and tedious reckoning if pebbles were used, are made at once with very little trouble. The four great methods are addition, subtraction, multiplication, and division, of which the last two are only ways of doing several of the first and second at once. When one number is increased by others, the second number, which is as large as all the numbers together, is called their sum. The process of finding this sum of two or more numbers is called addition, and, as was said before, is denoted by placing a cross between the numbers which are to be added together. Suppose it required to find the sum of 1,834 and 2,799. In order to add these numbers, take them to pieces, dividing each sum into units, tens, hundreds, and thousands. 1,834 is 1,800. 3 tens and 4. 2,799 is 2,700. 9 tens and 9. Each number is thus broken up into 4 parts. If to each part of the first you add the part of the second, which is under it, and then put together what you get from these additions, you will have added 1,834 and 2,799. In the first number are 4 units, and in the second 9, which will, when the numbers are added together, contribute 13 units to the sum. Again, the 3 tens in the first and the 9 tens in the second will contribute 12 tens to the sum. The 8 hundredths in the first and the 7 hundredths in the second will add 15 hundredths to the sum, and the 1,000 in the first with the 2 thousandths in the second will contribute 3 thousandths to the sum. Therefore, the sum required is 3,000, 15 hundredths, 12 tens, and 13 units. To simplify this result, you must recollect that 13 units are 1 10 and 3 units. 12 tens are 100 and 2 tens. 15 hundredths are 1,000 and 5 hundredths. 3 thousandths are 3 thousandths. Now, collect the numbers on the right hand side together, as was done before, and this will give as the sum of 1,834 and 2,799. 4 thousandths, 6 hundredths, 3 tens, and 3 units, which is written 4 6 3 3. The former process, written with the signs as follows: 1834 equals 1 times 1,000 plus 8 times 100 plus 3 times 10 plus 4. 2799 equals 2 times 1000 plus 7 times 100 plus 9 times 10 plus 9. Therefore, 1834 plus 2799 equals 3 times 1000 plus 15 times 100 plus 12 times 10 plus 13. But 13 equals 1 times 10 plus 3. 12 times 10 equals 1 times 100 plus 2 times 10. 15 times 100 equals 1 times 1000 plus 5 times 100. 3 times 1000 equals 3 times 1000. Therefore, 1834 plus 2799 equals 4 times 1000 plus 6 times 100 plus 3 times 10 plus 3 equals 4, 6, 3, 3. The same process is to be followed in all cases, but not at the same length. In order to be able to go through it, you must know how to add together the simple numbers. This can only be done by memory. Suppose you want to find the sum of 8 and 10 using a grid of numbers. Look in the left-hand column for either of them. 8, for example, and look in the top column for 7 on the same line as 8 and underneath 7. You find their sum, 15. When this table has been thoroughly committed to memory, so that you can tell at once the sum of any two numbers, neither of which exceeds 9. You should exercise yourself in adding and subtracting two numbers, one of which is greater than 9 and the other less. You should write down a great number of such sentences as the following, which will exercise you at the same time in addition and in the use of the signs mentioned. 12 plus 6 equals 18. 22 plus 6 equals 28. 19 plus 8 equals 27. 54 plus 9 equals 63. 56 plus 7 equals 63. 22 plus 8 equals 30. 100 minus 9 equals 91. 27 minus 8 equals 19. 44 minus 6 equals 38, and so on. When the last two articles have been thoroughly studied, you will be able to find the sum of any numbers by the following process, which is the same as above. Rule 1. Place the numbers under one another, units under units, tens under tens, and so on. Add together the units of all and part the whole number thus obtained into units and tens. Thus, if 85 be the number parted into 8 tens and 5 units, if 136 be the number parted into 13 tens and 6 units, write down the units of this number under the units of the rest, and keep in memory the number of tens. Add together all the numbers in the column of tens, remembering to take in or carry, as it is called, the tens which you were told to recollect above, and divide this number of tens into tens and hundreds. Thus, if 335 tens be the number obtained, part this into 33 hundreds and 5 tens. Place the number of tens under tens, and remember the number of hundreds. Proceed in this way through every column, and at the last column, instead of separating the number you obtain into two parts, write it all down before the rest. Example: what is 1805 plus 36 plus 1927 plus 3 plus 1474 plus 2008? The answer is 25053. The addition of the units line, or 8 plus 4 plus 3 plus 7 plus 6 plus 5 gives 33. That is 3 tens and 3 units. Put 3 in the units place and add together the line of tens, taking in at the beginning the 3 tens which were created by the addition of the units line. That is, find 3 plus 0 plus 7 plus 2 plus 3 plus 0, which gives 15 for the number of tens. That is 105 tens. Add the line of hundreds together, taking care to add the 100 which arose in the addition of the line of tens. That is find 1 plus 0 plus 4 plus 7 plus 8, which gives exactly 20 hundredths, or 2 thousands and no hundredths. Put a cipher in the hundreds place, because if you do not, the next figure will be taken for hundreds instead of thousands. And add the figures in the 10 thousands line together, remembering the 2 thousands which arose from the hundreds line. That is, find 2 plus 2 plus 1 plus 9 plus 1, which gives 15 thousands, or 1/10 and 5,000. Write 5 under the line of thousands, and collect the figures in the tens of thousands line, remembering the 10,000 which arose out of the thousands line. That is, find 1 plus 1, or 2 10,000s. Write 2 under the 10,000s line, and the operation is complete. If 2 numbers must be added together, it will not alter the sum. If you take away a part of one, provided you put on as much to the other, it is plain that you will not alter the whole number of a collection of pebbles in 2 baskets by taking any number out of one and putting them into the other. Thus, 15 plus 7 is the same as 12 plus 10, since 12 plus 3 is 3 less than 15, and 10 is 3 more than 7. This was the principle upon which the whole process above was conducted. Let A and B stand for 2 numbers. it is impossible to tell what their sum will be until the numbers themselves are known. In the meanwhile, A plus B stands for this sum. To say in algebraic language that the sum of A and B is not altered by adding C to A, provided we take away C from B, we have the following equation. A plus C plus B minus C equals A plus B, which may be written with or without brackets. The meaning of these two equations will appear to be the same on consideration. If A be taken twice, 3 times, etc., the results are represented in algebra by 2A, 3A, 4A, etc. The sum of any two of this series may be expressed in a shorter form than by writing the sign plus between them, for though we do not know what number A stands for, we know that, be it what it may, 2A plus 2A equals 4A. 3A plus 2A equals 5. 4A plus 9A equals 13A. And generally, if A taken M times be added to A taken N times, the result is A taken M plus N times, or MA plus NA equals M plus NA. The use of the brackets must here be noticed. They mean that the expression contained inside them must be used exactly as a single letter would be used in the same place. Thus, PA signifies that A is taken P times, and M plus N A, that is taken m plus n times. It is, therefore, a different thing from m plus na, which means that a, after being taken n times, is added to m. Thus, 3 plus 4 times 2 is 7 times 2, or 14, while 3 plus 4 times 2 is 3 plus 8, or 11. When one number is taken away from another, the number which is left is called the difference or remainder. The process of finding the difference is called subtraction. The number which is to be taken away must be, of course, the lesser of the two. The process of subtraction depends upon these two principles. The difference of two numbers is not altered by adding a number to the first. If you add the same number to the second, or by subtracting a number from the first, if you subtract the same number from the second. Conceive two baskets with pebbles in them, in the first of which are 100 pebbles more than the second. If I put 50 more pebbles into each of them, there are still only 100 more in the first than in the second. And the same if I take 50 from each. Therefore, in finding the difference of two numbers, if it should be convenient, I may add any one number I please to both of them, because though I alter the numbers themselves by doing so, I do not alter their difference. Since 6 exceeds 4 by 2, and 3 exceeds 2 by 1, and 12 exceeds 5 by 7. 6, 3, and 12 together, or 21, exceed 4, 2, and 5 together, by 2, 1, and 7 together, or 10. The same thing may be said of any other numbers. If A, B, and C be 3 numbers, of which A is greater than B, it leads to the following. A plus C minus B plus C equals A minus B. Again, if C be less than A and B, A minus C minus B minus C equals A minus B. The brackets cannot be removed here as in addition. That is, P minus Q minus R is not the same as P minus Q minus R. For in the first, the difference of Q and R is subtracted from P, but in the second, first Q and then R are subtracted from P, which is the same as subtracting as much as Q minus R together, or Q plus R. Therefore, P minus Q minus R is P minus Q plus R. In order to show how to remove the brackets from P minus Q minus R without altering the value of the result, let us take the simple instance 12 minus 8 minus 5. If we subtract 8 from 12, or form 12 minus 8, we subtract too much, because it is not 8 which is to be taken away, but as much of 8 as is left after diminishing it by 5. In forming 12 minus 8, we have therefore subtracted 5 too much. This must be set right by adding 5 to the result, which gives 12 minus 8 plus 5, for the value of 12 minus 8 minus 5. The same reasoning applies to every case. Therefore, we have P minus Q plus R equals P minus Q minus R. P minus Q minus R equals P minus Q plus R. By the same kind of reasoning, A minus B plus C minus D minus E equals A minus B minus C plus D plus E. 2A plus 3B minus A minus 2B equals 2A plus 3B minus A plus 2B equals A plus 5B. 4x plus y minus 17x minus 9y equals 4x plus y minus 17x plus 9y equals 10y minus 13x. I want to find the difference of the numbers 57,762 and 34,631. Take these to pieces as above, and 57,762 is 5 tenths, 7 thousandths, 7 hundredths, 6 tens, and 2 units. 3, 4, 6, 3, 1 is 3 10,000ths, 4 thousandths, 6 hundredths, 3 tens, and 1 unit. Now 2 units exceed 1 unit by 1 unit. 6 tens, 3 tens, 3 tens, 7 hundredths exceed 6 hundredths by 1 hundred. 7 thousandths exceed 4 thousandths by 3 thousandths. 5 10,000ths exceed 3 10,000ths by 2 10,000ths. Therefore, all the first column together exceeds all the second column by all the third column. That is, by 2 10,000s, 100, 3 thousands, 3 tens, and 1 unit, which is 2, 3, 1, 3, 1. Therefore, the difference of 5, 7, 7, 6, 2 and 3, 4, 6, 3, 1 is 2, 3, 1, 3, 1, or 5, 7, 7, 6, 2 minus 3, 4, 6, 3, 1 equals 2, 3, 1, 3, 1. Suppose I want to find the difference between 61,274 and 39,628. Write them at length, and 6, 1, 2, 7, 4 is 6 10,000s, 1,000, 2 hundreds, 7 tens, and 4 units. 3, 9, 6, 2, 8 is 3 10,000s, 9 thousands, 6 hundreds, 2 tens, and 8 units. If we attempt to do the same as in the last article, there is a difficulty immediately, since 8, being greater than 4, cannot be taken from it. But from 40, it appears that we shall not alter the difference of two numbers if we add the same number to both of them. Add 10 to the first number. That is, let there be 14 units instead of 4. And add 10 also to the second number. But instead of adding 10 to the number of units, add 1 to the number of tens, which is the same thing. The numbers will then stand thus: 6 10,000s, 1,000, 2 hundreds, 7 tens, and 14 units. 3 10,000s, 9 thousands, 6 hundreds, 3 tens, and 8 units. You now see that the units and tens in the lower can be subtracted from those in the upper line, but that the hundreds cannot. To remedy this, add 1,000 or 10 hundreds to both numbers, which will not alter their difference, and remember to increase the hundreds in the upper line by 10 and the thousands in the lower line by 1, which are the same thing. And since the thousands in the lower cannot be subtracted from the thousands in the upper line, add 1 10,000 or 10 thousands to both numbers, and increase the thousands in the upper line by 10 and the 10 thousands in the lower line by 1, which are the same things, and at the close the numbers which we get will be 10 10,000s, 11 thousands, 12 hundreds, 7 tens, and 14 units. 4 10,000s, 10 thousands, 6 hundreds, 3 tens, and 8 units. These numbers are not, it is true, the same as those given at the beginning, but their difference is the same. With the last mentioned numbers proceeded in the same way, which will give as their difference 2 10,000s, 1,000, 6 hundreds, 4 tens, and 6 units, which is 2 1 6 4 6. From this, we deduce the following rules for subtraction. Write the number which is to be subtracted, which is, of course, the lesser of the two, and is called the subtractahend, under the other, so that its units shall fall under the units of the other, and so on. Subtract each figure of the lower line from the one above it, if that can be done. Where that cannot be done, add 10 to the upper figure, and then subtract the lower figure. But recollect, in this case, always to increase the next figure in the lower line by 1 before you begin to subtract it from the upper one. if there should not be as many figures in the lower line as in the upper one, proceed as if there were as many ciphers at the beginning of the lower line as will make the number of figures equal. You do not alter a number by placing ciphers at the beginning of it. For example, 0, 0, 8, 1, 8 is the same number as 8, 1, 8, for it means 0 10,000s, 0 thousands, 8 hundreds, 1 10, and 8 units. The first two signs are nothing, and the rest is 8 hundreds, 1 10, and 8 units, or 8 1 8. The second does not differ from the first, except in its being said that there are no thousands and no tens of thousands in the number, which may be known without their being mentioned at all. You may ask, perhaps, why this does not apply to a cipher placed in the middle of a number or at the right of it, as, for example, 2 8 0 0 7 and 3 9 7 0 0. But you must recollect that if it were not for the two ciphers in the first, the 8 would be taken for 8 tens instead of 8 thousands, and if it were not for the cipher in the second, the 7 would be taken for 7 units instead of 7 hundreds. Example: what is the difference between 3 7 0 8 2 9 1 6 4 0 0 3 0 1 7 4 and 3 0 8 1 3 6 4 9 2 7 6 1 8 8? The answer is 3 6 7 7 4 7 7 9 9 0 7 5 3 9 8 6. Exercises. What is 1 8 3 3 7 plus 1 4 2, 6, 3, 2, 0, 0, minus 6, 4, 7, 2, 9, 0, 2. The answer is 1, 4, 2, 8, 0, 8, 6, 3, 5. What is 1,000 minus 6, 4, 6 plus 3, 2, 7, 9 minus 6, 4, 6? The answer is 3, 1, 6, 9. Six, 4 plus 7, 6 plus 1, 4, 4 minus 18, and subtract from that 3, 3 minus 2 plus 1, 0, 0, 0, 3, 7. And the answer is 9, 9, 8, 0, 2. What shorter rule might be made for subtractions when all the figures in the upper line are ciphers except the first? For example, in finding 100 million minus 2, 7, 3, 1, 6, 3, 4. In the following table, subtract B from A from the remainder, and so on until B can no longer be subtracted. Find how many times B can be subtracted from A, and what is the last remainder. 2, 3, 6, 0, 4. You can subtract B, which is 9, 9, 9, 9, 2 times, with a remainder of 3, 6, 0, 6. You can subtract 3, 7, 1, 7, 3 from 2, 0, 9, 9, 6, 1 5 times, with a remainder of 2, 4, 0, 9, 6. You can subtract 6, 7, 9, 2 from 7, 4, 7, 1, 2 11 times, with a remainder of 0. You can subtract 6, 5, 4, 3, 2, 1 from 4, 8, 0, 2, 4, 6, 9, 7 times, with a remainder of 2, 2, 2, 2, 2, 2. You can subtract 3, 1, 4, 1, 5, 9, 2 from 1, 8, 8, 4, 9, 7, 4, 7, 6 times, with a remainder of 1, 9, 5. Finally, you can subtract 1, 2, 3, 4, 5, 6, 7, 8, 9 from 9, 8, 7, 6, 5, 4, 3, 2, 1, 8 times, with a remainder of 9. Thank you so much for joining me in today's math lecture. I hope to see you soon.